Okay, no. So, no, well, what? Well, yeah, if it's the same variable, it has to be the same guy. Okay? Yeah, the K has to be the same. If they wanted it to be a different number, they would put a different variable up. Okay? Let's talk about this. It says find K if a line that has a slope of negative 3/8 passes through the points 2, comma, K minus 3 and 3K, comma, 10. It says use the slope formula. Now, slope formula, in order to use the slope formula, what did we say last week that I want you to do first? You're going to use the slope formula. What should we do first? Label your ordered pairs. It's x1, y1, and x2, y2. By the way, when you pass back the homework, some of you will see if you didn't do that. That was not a smart thing. Just throw that out there. So when you get it back, you see like 25 or 33. I say, I told you so. I told you so. So now we're going to fill in our equation. Remember, I want it done like this. What goes in the first parentheses? Y2. It's the formula. That's why we label them. So we have 10 minus K minus 3 over 3K minus 2. And when we simplify this, you'll notice a subtraction in front of parentheses. If you remember, we want to make sure we distribute that evenly. So we end up with 10 minus K plus 3 over 3K minus 2. Is anybody not sure how I ended up with this? We still can simplify because we have like terms. We have the 10 plus the 3. So what we really end up with, guys, is 13 minus K over 3K minus 2. Now, before I take the next step, is there anyone who's not sure how I ended up with this? This is essentially the slope between these 2 points. Ian?
I'm kind of confused like what you did at the first part with 10 minus.
Which part? You're confused with when I filled them in or when I simplified it?
It said 10 minus parentheses K minus 3.
Yeah, because it's Y2 minus Y1. So it's 10 minus K minus 3.
There's no longer those parentheses around the K.
When you pull the parentheses, you're subtracting. If you write 4 minus 2 plus 3, this is 4 minus 2 minus 3. You distribute your subtraction sign to both terms. Got it? That's a very common error if you're not paying attention. So does everyone understand that this is essentially the slope of the line between the 2 points? It doesn't look like slope, but it is. Now, what did they tell us the slope was? It was negative 3/8. Now, and I told you, when there's a negative out front, where do I want you to put it? The numerator. So watch what happens. What we end up with is 13 minus K over 3K minus 2, which is our slope, yes? Therefore, it has to be equal to negative 3/8. What happens when we have a proportion with variables? What should we do? We cross multiply. And we end up with negative 3 times 3K minus 2 equals 8 times 13 minus K. And when we simplify, we end up with negative 9K plus 6 equals 13 times 8, 104 minus 8K. Agree? See where I'm going with this? So what's my goal now, guys? What's my goal in any equation when I have variables all over the place? Get the variables on one side and numbers to the other. So I'm going to add a K to both sides. That gives me negative 1K on this side. I'm going to subtract 6 from both sides. And it equals 98. When I divide both sides by negative 1, K equals negative 98. It becomes simply an equation. When you get variables in ordered pairs, it doesn't mean you can't do anything with them. It it just means you have to begin working through it algebraically, using the slope formula. It's honestly the only time I ever use the slope formula. It's the only time I ever use the slope formula. And by the way, what that means is that if you put negative 98 in for k up here and do all the work, the slope through those 2 points is negative 3/8. Any questions on that?
That's a pretty big thing.
It is. But the coordinate grid is a very big thing. Right? Coordinate grid goes on and on, much further outside of what we can see. The coordinate grid isn't just a 10 by 10 thing, right? Because it has those arrows. It goes forever.
Or you can just change the scale.
You can change the what? There is no scale. It's by ones. Right? Okay. All right, so here we go. Now we're going to learn about the linear parent function. Guys, everything has a parent. And our lines have a parent too, and it's called the linear parent function. And just like your parent, theoretically, the linear parent will always be the linear parent. There is no substitute, there is no replacement, there is no adjustment, there's a babysitter temporarily, but the parent comes back. The linear parent is the line that we compare all other lines to. The linear parent function is the line that we compare all other lines to. Okay? And I'll show you what the linear parent looks like. First of all, it has an equation. And it's an equation you need to memorize. And the equation is y equals x. The line y equals x is the linear parent function. It is the only linear parent function. It will be the linear parent function this year, next year, and the year after. Never changes. Okay? And if in your head you begin thinking about what that linear parent function looks like, yes, sir? You can make a table. If we were to make a table, by the way, I want you to get into the habit of using these input values. And some of my kids last year, remember we would draw a line, we would always use -2, -1, 0, 1, 2. Those are your x's. You can decide on your x's, and then when you plug your x into your equation, it will find the y's for you. Put in your input, create your output. It is -2, -1, 0, 1, and 2. That's how you create the table. So that table represents 5 of the x, y ordered pairs for the linear parent function. You also create a mapping diagram. It's kind of easy. It looks like a ladder. Because each one's going straight across to the other one, because the y value equals the x value. Now, what do you think it looks like on a graph? If you think about those ordered pairs on a graph, what do you think it looks like, Tristan? Up 1 over 1 from where? The origin. Very good. It's exactly what it looks like. It is a perfect 45-degree diagonal line through the origin. It is a perfect 45-degree diagonal line through the origin. That is the linear parent. It is neither steep nor flat because it is going up, it is rising at the same rate that it is running. Its y-intercept is what? It's 0. That's why the equation looks like this. There is no plus or minus anything. It goes through the origin. Therefore, the y-intercept is it. In fact, if we were to describe it, we would say it goes through the origin. It also goes through 1, 1, 2, 2, 3, 3, etc. It is continuous and it continues. And those are 2 different terms. I want to talk about them. Do you remember discrete versus continuous? How did we know something was continuous? Very good. If the dots were connected, right? To be continuing means it goes on and on forever. To be continuous means it just has to be connected. If you look at a line segment that's this long, this is continuous, but it is not continuing.
If it was continuing, you would have arrows.
If it would have to have arrows to be continuing. So there's one mathematical definition for continuous, There's a mathematical definition for continuing, and they're different. Okay? The domain. What's the domain of that function? All real numbers. It goes on and on forever in both directions. So it's negative infinity to positive infinity or all real numbers. What's the range? Very good. It's got the exact same range. Negative infinity to positive infinity or all real numbers. Everybody remember domain and range? Don't forget domain and range. Muy importante. And the x-intercept and the y-intercept are both at 0, 0. We would say this line is increasing because it goes up from the left to the right. It is an increasing line that goes up from the left to the right. What is the m value? What is the slope? The slope is 1. Very good. Remember, you look for the coefficient of x. The coefficient of x is the m. And the b value is 0. So the equation actually looks like that. Avery?
You know what the parent lines, can they ever go decreasing?
This is the only parent line. Guys, you'll never see a parent function that looks anything other than what you see on the board. It is the only linear parent function. Now, there's a quadratic parent function when we get to quadratics. There's an absolute value parent function when you get to algebra 2 instead of the absolute value function. The square root function, the cube function. Every base function has a parent. Every base, and this is just a linear parent function. So this is the parent function of all lines. Okay? So, here's what we're going to practice today. Does anybody have questions about the linear parent function? Here, let's try something. If I were to write this, I'll write this equation. Someone tell me something they know about that line based off of the slope. What's the slope, first of all? Right, that's 8, right? Tell me something you know about that line if we were to graph it. It's increasing. I agree. It is an increasing line. What else do we know about that line? It is steep because it is going up 8 over 1, up 8 over 1, right? What does the negative 2 represent? What does that minus 2 represent? The y-intercept. So here's what I want you to be able to do, peeps. I want you to be able to mentally create an image for that line. Because you should not only know what the line looks like, you should know where it crosses the y-axis. You should know what it looks like on a coordinate grid without ever putting your pencil on your paper. You should know exactly what it looks like. Because it is an increasing steep line, up 8 over 1, that crosses the y-intercept at negative 2. What about this one? Don't say it out loud, just run off your checklist. Compared to the linear parent function, what does that line look like? Is it more steep or less steep? Is it, okay, just listen. Is it more steep or less steep? Is it above the linear parent or below the linear parent as far as the y-intercept is concerned? Is it going the same direction as the linear parent, or is it going the opposite direction as the linear parent? Those are the mental things I want you going through. What do we know about this? Is it more steep or less steep? It is less steep because the linear parent's going up 1 over 1. This one's going down 2 over 3, so it's more flat. If it's more flat, it's less steep. If it's more flat, it's less steep. What about the y-intercept? Is it above or below the linear parent? It's above. In fact, we know exactly where it is. It's exactly 5 above the linear parent. And is it going the same direction or the opposite? It's going the opposite direction. I want you to get to a place where you can begin to do that in your head. Now, in order to do that, you must have your equation in slope-intercept form. Slope-intercept form is what allows you to create a mental image of your line. So let's try that. So the first question is, on number 1, is it in slope-intercept form? It is not. So what must we do algebraically to get it there? By the way, you will never tell me the slope or the y-intercept until you have the slope-intercept form. Do not try to tell me the slope of the y-intercept unless it's the slope-intercept form. What do we do first? Very good. We subtract 6x. We subtract 6x from both sides, which leaves us with, how do we write it?
Negative y equals negative 6x.
Perfect. So it's very good. Negative y equals negative 6x plus 11. Because I want the x term first, and we want to make sure we're being careful with all negative signs. What do we do now because it's still not in slope-intercept form? Madison?
Divide everything by
Perfect. We're going to divide everything by negative 1 individually. And what we end up with is y equals 6x minus 11. Please don't write plus negative 11. Do not write plus negative 11. We don't do that anymore. Okay? What is the slope?
6.
Very good. And if you think about it as a fraction of 6 over 1, is it steep or is it not steep? Steep, increasing or decreasing? Increasing y-intercept? Negative 11. Negative 11. Do the same thing with number 2. Put number 2 in slope-intercept form, find me the slope of the y-intercept, and then create a mental picture of that line compared to the linear parent. Which is one. Another line. That's all true. It is. Should have gotten a slope of negative 1/4 and a y-intercept of 2. Everyone get that?
Yeah.
Okay, let's go through a description. Someone give me one description of that line compared to the linear parent. Avery. It's decreasing. So, by the way, the word we would use if it's going the opposite direction from the linear parent, we would say it's reflected. Remember reflected? So we wouldn't say it's like going the opposite direction. We would actually, mathematically, you would say it's reflected. Tristan? It is less steep. Because again, if it's more flat, it's less steep. Okay? Last thing. Someone give me, is it above or below and by how many?
No, well, it's above.
Why?
Two.
What?
The little, actually,
Mamie, what do you think? It's above by 2. It's above by 2 because it crosses the y-axis at positive 2. Where does the linear parent cross the y-axis? At the origin. So it has to be above it by 2. Get that? Okay. By the way, we would call that a shift up 2. So it's shifted up 2. It's reflected because it went from increasing to decreasing, and it's less steep. Okay? Let's try a couple more, and then we'll get to it. First step, subtract x, yes? Then we end up, by the way, make sure that this comes with the negative. So it's negative 7y equals negative x plus 42. And what do we want to do next?
Even 5 by 7.
That's not what's in front of the y.
Negative 7.
Thank you. I divide everything by negative 7. Now we end up with y equals, how does that tell you to write x over 7?
1/7.
Very good. 1/7 x. 1/7 x. Negative divided by negative is a positive. Write it as 1/7 x minus 6. My slope is 1/7. My y-intercept is negative 6. And finally, we subtract 9x. We end up with 3y equals negative 9x minus 3. Divide everything by positive 3. We end up with y equals negative 3x minus 1. Please don't tell me 3 divided by 3 is 0. Can't tell you how many students do that. It doesn't know. Okay? And we end up with a slope of negative 3 and a y-intercept of -1. Guys, as you can see, if you can manipulate the equations, this goes very, very quickly. That being said, I want you doing more than manipulating the equations. I need you every time to think about, go through your mental checklist. Is it more or less steep than the linear parent? Is it reflected or not reflected against the linear parent? Is it shifted up or shifted down based off the y-intercept of the linear parent? Those are going to serve you well if you can begin to do it. Classwork, no homework, ready, set, go. Oh, you have stuff in the outbasket to clear.